Hi, everyone. Welcome to Between the Brackets. I am Kyle Paul. I am regional lead for developer ecosystems here in North America, where we look after all the different community programs like Google Developer Groups, Women Tech Makers, Google Developer Student Clubs, and of course, our Google Developer Experts program. And these are all, you can find links to all of this and learn more about all of our programs at g.co/dev/community. And we do shows like this and events out in the community to help bring you more interesting stuff about Google technologies and help you to build your next cool app. And with that, on Between the Brackets, we have since it's April and Android rhymes with April somehow, I guess. But so we're going to be talking about Android and Kotlin today. And we have with us Stacy Devino, who is the principal Android engineer at Stitch Fix. And she's here with us today to talk about how to make your Android and Kotlin apps future-proof. And through this, we're going to be talking about Kotlin Gradle DSL, KMP, ProGuard, Jetpack Compose. There's a lot of new stuff that came out with Jetpack Compose that we're really excited to dive into. And so without further ado, I'd like to bring Stacy onto the stage.
Hi, Kyle. How's it going?
Awesome. Welcome to Between the Brackets.
I'm between.
Yes. Welcome. So how are things?
Things are wonderful. It's a little darker day than usual here in Texas, but otherwise doing pretty well myself.
Awesome.
Great. Got my Google Developers Latte on right now.
Nice. Yeah, it is springtime, and springtime in the Midwest, there's a lot of storms and stuff. So hopefully, you're safe and there's not going to be too much precipitation there for you. I know Texas loves to get the rain. So, but go ahead and tell us, a little bit more about your background, some of the stuff that you're doing with Stitch Fix, and what excites you about Android.
So, a little bit about me. I've been doing mobile development back since like the Palm 1. Back in middle school, I was that kid. Sold all my Game Boys, everything else to get a Palm 1 because that level of nerd.
Nice.
But I've been doing Android development basically since 2009. So I guess it's well over a decade now, which is crazy. Very end of 2009 once kind of 1.0 showed up. So I guess in terms of everything else, I kind of started out in operating system side of things, working a lot in the open source community, Cyanogen, if that rings any bells for folks. Was definitely a constant lurker on the IRC channels, and did a couple and helped with a couple ports. Did some professional work around that as well, and then migrated to kind of a mix roles and eventually to pure app development, where I have had my focus for at least the last 6 years. So definitely been a journey, and really excited to be where I currently am with Stitch Fix and all the wonderful things that we are kind of getting to build from scratch in terms of our platform.
That's amazing. And so what are some new things that you're excited about with Android?
So there's a couple of really great avenues that are happening right now. We've been seeing a lot of push around Jetpack Compose and kind of composables. If you've been following the web world at all, you've seen how Vue.js has really sparked that kind of thought process, which then we saw get into Dart and that permeate as Flutter. And then you can see the direct influence of Flutter into the Jetpack Compose, which in turn is now become just Kotlin Compose, right? Because that's actually just a copy of it. So you're kind of gaining multiple skill sets through just that one avenue. So I know that we're really excited about it from an Android developer's perspective, but I'm really excited about it because it's opened up our skill sets to a whole bunch of other avenues. And that's just from the Compose side of things. So also, I'm really excited with what's happening in Kotlin multi-platform, Kotlin multi-mobile, and how we're seeing tool sets really expand the value of what it means to be an Android developer, and to even think of ourselves not even necessarily as Android developers, but solution engineers, and the ability to have our work have much more value than just the device that's in your pocket. So,
Right.
and we'll touch
And
a little
that's,
on
yeah,
that.
we'll dive into that a little bit more. But yeah, it's I want to touch on something like that you mentioned, where where Android is going. Like Android has kind of been doing this for a few years, but everybody, when you hear Android, everybody thinks of the device in their pocket, their mobile phone. But Android actually operates on a lot of different surfaces, where it's there's Android Auto, you have the Wear OS for your watches, you have Android and a bunch of different things like your point of sale systems, and
A
so
number
like
of medical devices.
medical devices. Yeah,
That it's actually become the system of choice in a number of medical devices, especially ones that are a little bit more complicated. We've also seen that take over as the core in a lot of smart devices. You mentioned Auto. Well, even if they aren't necessarily using the true Android Auto OS, they in a lot of cases are actually running Android under the hood. And we do still have a few remnants of Android things kicking around as well. So, you know,
yes,
uh, there is so much more value than you even see on the immediate surface. So many times, anything that you even interact with, especially any kind of fancier advertisement system, a lot of those displays actually are running Android OS internally, even if they might only be rendering some sort of web view.
definitely. Yeah. I remember like when you're walking through the airport or any malls, you'll see those. Sometimes there's a little standee with a touchscreen that you can like, where do I find this store in the mall? Or as you were talking about, that little advertisement playing. It's all Android. So yeah, it's Android's everywhere, and there's the possibilities of making something that's on a multi-platform, multi-surface is just growing exponentially.
Absolutely. Why not? I mean, it's free, open, and distributable. How
Definitely.
many mature operating systems run on small devices and can say that?
Exactly. So that's where we're going to get into how to make your apps future proof on it, but also be able to run on all of these different types of platforms. To where like because most of us, like I was saying, we hear Android and we always think of just the phone, but there's so many different avenues. And so like with Android, like what is your favorite thing that you've worked on with Android?
I guess
Is it a device? Is it like a project you've hacked on?
I would actually say it's the ability to make like one project or code that I've written actually apply to multiple applications and even different hardware. That's actually some of the cool parts, right? So one thing you should probably realize is a lot of the scanners that exist in retail operations and even warehousing, those are also running Android. So if you are working in some sort of retail application, there's a high possibility that code that you're actually writing could be used to help manage things in the warehouse or help customers find product. Or even if you're not working in that avenue, there's ways for you to maybe contribute on some of that stuff,
Awesome. Yeah.
and see your code show up in other places. Not necessarily always. There's other things I do that are not necessarily Android, but it's been really cool to find out like feedback later that 2 years later we've sold hundreds of these devices that you designed, and they've been rock steady for some big top 10 tech company names. They don't know that I built it or designed it, so it's great. But
Yeah. It's just cool to know that something that you worked on was mass distributed and it's been benefiting and obviously helping them turn a profit. So it's very cool. And obviously, it's been invaluable during this time of the pandemic and stuff when a lot of us are doing ordering from home, and whether it's stuff we need or don't need, there's like as you're talking about all these warehousing and the distribution, it's invaluable on that, especially during this time. But
oh yeah.
you bring up a good point with you mentioned modularity, and so like how you are tying all of this together, where you've developed I don't want to necessarily call it a framework, but an architecture, I guess would be the right word, to like how you've designed apps to be able to flex and go on these different surfaces. Can you talk a little bit about the importance of architecture?
Yeah, so actually, this also ties in directly to a lot of things I wanted to bring up with Kotlin Gradle DSL and being
Oh,
able to enable this kind of thought process. So, I personally follow the idea that highly modular apps make for good architecture because it forces you to actually separate out your concerns and to really think about reusability as a like kind of core construct. And in order to make good modular code, you need to kind of have an architecture set around that. And when we think about modular code, don't think about it as purely how do I make Android code, especially now in these times. I can make Kotlin modules that interact with Android modules, and I can have them in the same code base. I can even make modules that are wrappers for web content, for
mm,
Flutter content, so that now I can bring in distributables. And when we think about modularity even further, now you can start thinking about how do I make modules that actually compile as libraries? So I can distribute this and make it so that this code can actually go into multiple avenues, whether or not I have a direct hand in it or not. And that's kind of a big scope, but there's a lot of things that you can do to really set yourself up for success. It becomes really hard to do a lot of fully modular applications like that, or fully modular code bases or separate code bases. When you're kind of going down the groovy Gradle train, you can do it. It's just, it's not as easy as you would like to separate out your concerns. And then you really don't get the ability to build out with a lot of the core knowledge that you already have. We are not Android developers anymore. We are Kotlin developers. So
true.
part of that is that whole mind framework change. And how do we enable fast deliverables on our platform while making sure that we are always having our end user in our mind, right? And how do we even separate out, in terms of modularity, how do we even separate out concerns when we're working with third-party libraries? And how do we make sure that, okay, this goes into here and it doesn't touch this other thing that this depends on, and all of that kind of stuff. It can be a real help to your mind in a lot of ways, just because it forces good code organization practices in a lot of ways. Not only that, it decreases your compile times a lot.
True.
A
Yeah,
lot.
when you narrow down your dependencies, and yeah, because that's one thing that I've seen with, you bring in a lot of libraries. There's sometimes it's very heavy on the dependencies, and so if you can narrow, tree shake that down a little bit on your own with how you're building out your module or your library, that's very helpful to your app in the future, and how you, if you bring that library into another app that you're building, for example, to where I guess it could be helpful too, where let's say you are a contractor developer and you don't want to bring source code from one app into a new contract app, because there could be underlying issues legally too that you want to try and avoid.
Oh yeah, and another thing to think about is you're going to be able to take advantage of the fact that we have multi-threaded processors, and now we have much better compilers that are actually operating in a multi-threaded capacity, that when you actually have everything all split out, it can actually grab things and compile those individually and smack it together. So I can tell you from my own experience that we've seen as much as 70% or more lower costs in terms of building by switching out our Groovy scripts to Kotlin scripts and moving everything to modules. Even just the modules, and then there's even more you get with the Kotlin Gradle DSL, because they put a lot of great optimizations in, especially in the latest iteration, coming past like Gradle 6.3.4 or something along those lines and above. They've been really adding a lot to that.
Awesome. And I do have questions for you on the Kotlin Gradle DSL, but if you saw our note down there at the bottom, to all of our viewers, if you do have questions for Stacy, please ask them in our live chat over here on the side. We will be taking live questions. So if you have questions on the Kotlin Gradle DSL, KMP, ProGuard, Jetpack Compose, I know Stacy is very excited to receive your questions. And I'm excited because that means I'm not asking her all the questions. So, so on on your Kotlin Gradle DSL build scripts. So those of you who aren't necessarily aware, because this is something that's relatively new, right?
Well, it's been kicking around for the last 2 years, but it hasn't necessarily seen the kind of mainstream adoption. And there's kind of a lot of reasons behind this. And one of those is it's not very well outlined how to do it, which I'm actually working on. I'm hoping to have something out this weekend. I actually started updating a bunch of projects. So there'll be concrete examples of how to go from one stage to the next stage as part of that. So you don't have to just go, oh, how do I even understand how this correlates to this and all that kind of stuff? Because there are some distinct differences. And a lot of it is if you kind of look at first Kotlin specific projects that already have that inherent, which it just is. That just is the way it is. For the most part, yes, you can use Groovy Gradle as well, but you'll see that a lot more of the examples, especially from JetBrains Kotlin examples, are going to be that very modern Kotlin Gradle DSL. But there's a lot of things that are very specific to Android developers and to Android build scripts that we all know have been doing this a while. How you can't just take even just straight Groovy Gradle and like throw it into your Android project, because there are some specific differences in the way that we handle project dependencies are a little different. The way that we handle all projects, build like the core build scripts, things along those lines. Even the way that we do modules is a little different because they're all kind of relatively top level for the most part. We don't do the kind of sub of sub of sub. So those are some interesting things. I was going
to back up really quick on the architecture part. So to give some background, I do have some mobile developer experience, but my experience lies a little bit more on the website. And so that's where, when I'm building out a web app, the architecture, one of the architectures out there is MVC. So your module, view, controller, and how you're setting that up. That's just one of the many ways to architect a web application. So could you dive into a little bit more when you're modularizing your code in Android? Are there similarities there? Like what are your favorites? What ways do you recommend for architecting your apps?
So there is a little bit of a difference between modules and kind of what is a little bit more popular in the Android world at the moment is MVI, and you'll see a lot of stuff that's also MVVM and model view model, and then model view intent. Just want to clarify what those are in case anybody hasn't heard those terms before. Model view intent is in a lot of ways similar to MVC. But you really want to separate out your view from your logic and from what's actually containing and displaying that, right? So, and to a certain degree, MVVM is very similar. There's just kind of one extra step in there. And MVP is also very similar to Model View Presenter, if you're familiar. There is a lot of nomenclature when it comes to a lot of things in architecture, but modularity kind of exists as a level above that. When we're talking about core architecture, we're not necessarily talking about architecture patterns. When we're talking about actually splitting out your items. So like, let's say that you're making a product page, right? You're thinking, okay, well, product pages are used, so many places. Maybe I should just put this in my main app and put it in the core, right? Everybody gets the app module by default. So yeah, but why not make a product display page module, right? Like, and just call it the product page module, and it has dependencies on your core UI or your UI core for like all your themes and where a lot of your styles that everybody uses are going to be, but and perhaps even components like buttons and whatnot, and and then actually just build off of that so that anytime somebody needs to update something with the product page, they just go straight to there. They don't have to surf through all these things. And potentially one of the bigger points is a lot of times we are building not just for potentially multiple platforms, we're building with teams that have been growing. We've been seeing that the maturity in mobile platforms is getting there to the maturity a little bit closer that web teams have. So if you look at web teams, they split their front end, their back end, their native app platforms, all that kind of stuff. And they have different teams, and they might even work just on a single product or a single series of products. By splitting your code out into modules, you avoid a lot of interactions that will hold up PRs. Nothing is more frustrating. Pull requests.
Pull requests.
Yes. Everybody just kind of calls them PRs. I'm trying to be good about the nomenclature, but you do want to make sure that you are creating a positive environment for everybody who's working on that code. And one of the best ways is through modularity, because that way you are centralizing those interactions and making sure that one person's code does not affect another person's code. And you minimize those problems on pull requests, and even potentially thinking about splitting out certain backend services and things like that to entirely separate code bases, and have those build as libraries that you just interact with through there. There's a lot of things to think about that will kind of force you into good patterns that ultimately make it a lot easier to maintain. And kind of as another maintain thing, I know I keep adding onto things. What's really cool is if you actually build some of your modules or even your separated code bases to also support being built as libraries, then they can deploy separately, and you don't have to worry about some of the dependency interaction issues with other parts of your application or even other potentially completely different applications. So that's really helpful in a lot of ways.
For sure. And one thing just I want to highlight that you called out is like when you're modularizing your product page, it can extend the core UI of the app. And this way, if you've, for those viewers out there, if you haven't worked on a largely distributed team and stuff like that, when you're trying to update the UI for an app and there's multiple developers all working on it at the same time, just extending the UI makes it so much easier because you just update the UI. You don't have to go touch every single module or every single view to update the UI and make sure everything, like all the buttons, look like the same button and all that stuff. So I just wanted to highlight that, like just how much that simplifies and future-proofs your app by simplifying your code that way. So that was a huge tip that I wanted to make sure wasn't lost in the mix there. We do have a couple questions from the audience. I want to go ahead and call out the one from Kevin here. Have you tried a Jetpack Compose multi-platform project? Have you worked on one of those yet?
Not yet. And I think there's not necessarily multi-platform, yes. Jetpack Compose intermingled with that, not so much. So what you'll find right now is that you still really need to, especially if you're looking at iOS and Android, you might be able to share a lot of things in terms of your like KMP, but you're still going to have to write like some Swift UI, some Compose around that. I don't know what the status is on that kind of work at the moment. I imagine it's going on in rooms I'm not in, but I can definitely see the writing on the wall of, Jetpack Compose is Kotlin Compose, Kotlin Multiplatform, Kotlin Multimobile, Kotlin JS compiles, just throwing it out there. But I think I think we'll see a lot of progress in that if anything else has been an indicator. So I love how we're getting to really converged thoughts and frameworks in terms of UI building. That's one of the most frustrating things, kind of for any developer who writes code that eventually shows up on a screen. Is that like you got to keep learning all these new ways of thinking and all that, and it'd be nice to kind of just learn one or two frameworks and be done with it, honestly.
True. Yeah, it'd be interesting. Obviously, I can't speak to any of the future roadmap or anything like that with Jetpack Compose, but obviously stay tuned on our blogs and our Jetpack Compose docs. I know there's been a lot of stuff recently coming out with Jetpack Compose since February. There's a lot of stuff coming up with Android 12, so stay tuned on a lot of that. There's hopefully a lot more exciting things for all of you on the way. We do have another question here from Marat. Hopefully I'm saying your name correctly. Is there an automotive tool, or I assume automated tool, to migrate Gradle to Kotlin Gradle? Or is there a process that you're aware of to help migrate?
No. And this is and unfortunately enough, there's not even necessarily a really good guide, which is why I've been building one for a while. So I'm just trying to make sure all the avenues and everyone's had enough ability to actually go through it. But there is not a tool, but I can tell you that even on fairly large code bases, this hasn't been a thing that's taken substantially longer than like 2 weeks of or any kind of major, even in like really big constructs. Usually you run into some sort of issue with the maturity of a particular library or something along those lines. I did run into one of those with a particular alpha library in Android, but they quickly addressed it. So whoop whoop, we got a little fun going on with the video. Hopefully it'll be good in just a second. So yeah, there's kind of nothing, and that's why I'm building that specifically. There are so many great things that you get with Kotlin Gradle. First off, you get click-throughs, so you can write it actually in Kotlin, and you can do a lot because you have click-throughs, because you have Kotlin. You can do all the fun Kotlin things in terms of how you do your management. And there's even some extra stuff. So I don't know if you want us to dive into some of that or not, but
let's get one more question in here really quick from Shavam. It would be great. Do you have any references to a GitHub project that does a good job of being modular? So any open source projects that you're aware of that really shows off the modularity that we were talking about?
Well, I've actually been kind of tracking a lot of the things that are going on in Square's repositories, especially as they have been migrating all of their stuff
Square is in the payment processor, the point of service.
Square is open source. So if you aren't familiar, in at least in the Android world, Square is one of the big kahunas in terms of developing a lot of like core libraries that we use, like OKHTTP, and they've actually they started a lot of projects that ended up being forked and maintained by Google as well. Thinking to Dagger, which is forked and added upon to become Hilt, and even OKHTTP, a lot of other kind of core libraries. So there are some things that they actually have and that they've been splitting. I can probably try to do at least some sort of thing on mine as well. And this is actually one of the things I really wish there was a lot more resources on, even on the kind of Google developer page. Google developers pages for Android and things like that. But there are so many things that we could add in terms of learning.
For sure. Yeah, Yeah, one thing to add. So if you're on any Google site, if you see the feedback, it's usually in the top right or bottom right. There's a feedback button, and so on the documentation or any of our code labs, anything like that, you're more than welcome to submit feedback. Those do come in. We do see those. Well, we may not always respond directly back to you. That feedback does help us to build better documentation and all of that stuff.
Yeah,
And
and to kind of cite another kind of person, Don Felker's given some good discussions, and I think there's even some videos that he's put together on some of these topics as well. So also, he also open sourced his entire Kotlin training program. If anybody is interested in that, so please look at that on YouTube. Wonderful community person Don is. Hi, Don.
definitely. Hopefully Don's watching us. And I want to thank all of you for your great questions. Keep the questions coming. I want to hop over. So we have been talking about KMP. We've been taught you using that acronym. Can you dive in and tell us a little bit more about KMP and how we can use it today?
So Kotlin multi-platform. There's another one called Kotlin multi-mobile when we're thinking about it more in terms of Android and iOS. And I want to be very specific. When we talk about a lot of like multi-platform frameworks, most of them are like an emulator running on top of an emulator kind of situation, or a core running on top. Whereas Kotlin native is native, and it's acting like but it's acting exactly like the platform expects in terms of compiled code, which is a little bit different than what Flutter's doing, which is essentially relying on a lot of the like C core side of things in terms of rendering more like OpenGL and that kind of thing. If you're familiar with like game environment stuff, which it's still running like natively, but it's not running in kind of a typical app space, right? So that's one thing that's particularly different when we think about this in terms of mobile. But KMP, Kotlin multi-platform, is not just mobile. Kotlin multi-platform means we have web in terms of Kotlin JS, and we can build backend just like we can with any Kotlin app, right? So we can actually build a service that can actually exist on our backend, and then we can actually directly import and use it in our iOS projects and in our Android projects. So now we're talking about true multi-platform. And when I say Kotlin JS, there's actually a tool, Kotlin JS, I guess, that allows Kotlin code to actually compile down to JavaScript code. It may not be as optimized as writing it in pure JavaScript, but actually a lot of the feedback that I've been seeing is that the kind of overhead is relatively minimal. And when we talk about iOS and Android in Kotlin Multimobile or KMP, that actually has gotten a lot less in terms of computational or size overhead as well, especially from the iOS side of things. So when it used to be like as much as like, I think like 6K or something along that. But now it's down to like 1 or less than 1 in a lot of ways. I really highly want people to look at Touch Labs Camp Kit, some of the presentations that Kevin Galligan, hi Kevin, has given, and you know how they've actually been working a lot in terms of with Kotlin, with Google, with the open source community in general, to really build out a lot of those tool sets. And there is a lot of stuff that you don't realize under the hood is actually all written in Kotlin. There are some like analytics platforms that actually have written their base code in Kotlin, and it brings out all these different distributables for their client side. But they're only building for one code base. And there's a lot of other applications that are actually, I can't directly speak to this in some cases because I don't have brand authorization for other people, but there it's surprising. And when I was asking people in the community who is building with KMP and what are they seeing in terms of like Kotlin JS and all these other kind of components, because that is really an area that a lot of mobile developers, especially Android developers, we might see JavaScript so we can build our JavaScript interface, but we look at some React code and we're like, I'm done.
Yeah.
Um, so it can actually end up being extremely valuable for us, even in just being able to learn and translate those skills into JavaScript and kind of bring value.
For sure.
So.
Yeah. And that's where one of the things I want to jump back and touch on is you mentioned how you can use Kotlin to write backend for your apps and stuff like that. And so that's where, if you are a solo developer and you really only know Kotlin and you need a backend for your app naturally. And so like one of the services you could use is like Google Cloud Run, where you can write native Kotlin and as Cloud Run, and this way it helps with the backend processes, stuff like that. There's other ways that you can use Kotlin as backends, but yeah, this is just an example here of where I'm familiar with Kotlin as a backend, in those kind of situations, to where if it's a small or mid-sized team, you don't necessarily have to learn a new language in order to still put a backend together. Have you helped to build a backend or any
I've
experience?
definitely, yeah, I've actually, there's been jobs where I've owned backend or led a backend team in addition to the mobile service team. Some of those use C#, which thankfully was not too different from Java, but I had already had some experience in that. But I will even just say that Kotlin, from a purely being a functional programming language and the way that it's actually structured, means that you, as a person who knows Kotlin, it's very easy to jump into concepts like Swift. It's very easy for you to jump into Golang. I've been learning Golang, so I can kind of interact with some other services and things as well. But oh my goodness, I'm like, oh yeah, this is just, there's like a slight difference here, and I declare a little thing. You know what I mean? But
Yeah.
kind of that major hurdle of going from object-oriented to functional programming has already made you so much better in being able to speak to all these other platforms and capabilities.
Awesome. Very cool. Yeah, if you have any questions about KMP, I don't see any just yet in the chat, but if you want to know a little bit more about KMP, we do have a lot of excitement around the future of KMP in the chat. So we're excited to see where it goes to. But so how does, so we're on a build path here. So we're going from our Kotlin Gradle DSL. Now we're on building out our KMP. So how does all this feed to intertwine together?
So I want to kind of go back to the Kotlin Gradle DSL. It's not, there's kind of a way to think about this, and it's not just, okay, we converted our Gradle scripts from Groovy to Kotlin. Okay, that's the first step, right? But the real value, the thing that kind of enables all of this other conjecture to come together, is the build SRC. So this is actually a unique concept in Kotlin Gradle versus kind of the Groovy Gradle, right? Which means that we can entirely outside of our module, not in our modules at all, right? We can have our functions, we can have our core build scripts, we can have a whole bunch of other fun things that make it so that we can build all of these other components and share dependencies. And you can even build SRC, mind blowing here right now, as a Git submodule that can be imported by all of your other projects as you build them. So, and that could get automatically updated. So you never have to worry about it. But okay, so we highlighted a one little thing right here, which is dependencies outside of your code. This means that you can share versions, you can share dependency names, and all you are doing is declaring that you implement this dependency and implement this plugin. And you can make object files of vowels, right? that actually contain all, and sub object files where it makes sense. And let's talk about one extra thing. Okay, so now I've got all my stuff split into dependency files, and I've got those implemented by our different modules, and even my projects, my relatively top level projects can just import this. So your regular build.gradle.kts file for your app, not even the app module, can actually use this build SRC. So when you think about it being completely outside, it is actually completely outside, which is really, really great. But now that I have dependencies and those are all written in Kotlin, you know what else I get that I don't get in Groovy?
What's that?
Click-throughs.
Oh.
I can click through each of these dependencies, see which ones are used. I get automatic syntax highlighting. And I can see all of their versions and everything else like that. And now I can make version files where I'm just updating the version and it populates across all of them. Or I'm just everywhere. So you never have to worry about like, I got to go line by line every single time and update everything. I'm like updating one little thing. And it won't even potentially, sometimes it doesn't even catch it. It's like a difference in the build script. So now that we have our dependencies completely living outside, right?
Mm-hmm.
Now we can do better module splits because we know that those dependencies are going to be maintained between all of them. And now we just are declaring, variables rather than implementing entire things that now we have to worry about updating. Now this will it'll all get the new stuff, right?
Yeah.
But I talked a little bit about
this is where ProGuard comes in, right?
Yeah, so there's some things that come into this, right? So now I can make functions, and I can declare those in my build SRC. And one of those functions, at least that I've kind of done on a lot of my code bases, I can't remember exactly where I first saw this concept, but and please, come in, tell me, hey, I was the one who originally posted this. But ProGuard files. Every Android developer is familiar with this giant concoction that comes out of this just never-ending ProGuard file for your application, that it is nigh impossible to maintain when you add libraries, destroyed libraries. Things get updated. So maybe the ProGuard dependencies are not there because not every library is going to include those. And then you need to write your own if you're doing anything with a JavaScript interface or certain classes you need to keep for some other thing, or you're building a library, then you need to do the same thing.
Right. Versioning.
Oh yeah, just all kinds of fun things, and people can never remember what goes to what because the way that you organize it, should be kind of top down, and otherwise you'll be having comments forever. But now, because you can write functions, you can actually declare a file folder for your ProGuard, and you can split all of your ProGuard files into whatever they correlate to. And because you're just writing a file filter, you can actually assign that file filter that will essentially concatenate those for you as a line item for your ProGuard, like ProGuard files equals this on your on your actual build scripts, which is amazing because now I can have ones for OK HTTP, or well, they updated there, so you don't need to do it, but all these other libraries, or even just yourself. And then what's awesome about that is you can make sure to do that as a ProGuard folder in each module. So every module, you can just say, this is my ProGuard folder, these are my things, and I can do that same ProGuard assignment from that same build SRC, and it just automatically catches it for each one. And that's a really big issue because ProGuard is really important for keeping classes and DEX optimization, as well as obfuscation with R8. So this comes back to like a whole security thing. So if you're not doing a good job with your ProGuard, you are opening yourself up to actually being decompiled and potentially people finding ways to
app secrets
or
injections. I assume once you break out your ProGuard file into those more modularized sections of your ProGuard, is there a way to as part of the build to where it does it in a specific order, or does it just know based on the file structure how to bring everything together?
That's what the function just kind of is a filter and grabs those files and then just passes them
Okay.
for the ProGuard. So it's not even necessarily anything that's complicated, because ProGuard itself is structured to read those and interpret those appropriately. And you can say don't optimize or optimize passes and all that kind of stuff. You still have all the that its own language, but now you can really split them and make sure that you're making things maintainable, especially in conjecture with your build scripts and all of your dependencies, which can be kind of a nightmare, even on kind of any distributed. I would say if you've got an app with more than like 10,000 users, you probably have, at least 20 plus dependencies, right? So, think about it in terms of all that. And there's even hidden dependencies, because, something might require this and require that. But I talked a little bit about the ProGuard stuff. You know what else you can do?
What's that?
You can do automatic dependency conflict resolution.
Oh, no way.
Yeah. So since
Very
you
cool.
have, and this kind of already exists in the Groovy Gradle side of things, because you still have tasks just like you do, in Groovy Gradle, right? But now we can start to think about how we want to have those tasks execute other functions as part of automatic like configuration all conflict resolution, because version conflicts can be a real thing when you're working with third-party libraries that are not necessarily being used by everyone. So maybe they are
Or
a very small team, right?
Yeah, or if you haven't really been handling your dependencies very well.
Yep, or you're repeating them and all that kind of stuff. So you can
You're dependent on two different versions of the same library.
yeah. So you can write dependency conflict resolution stuff in there. I've definitely taken advantage of that, and you still get a lot of these things in the Groovy side of things, but they're not as obvious and they're not as easy to do. When you're writing it in Kotlin and when you have a build SRC, now we can really think about how we make that distributable, how we make that accessible and maintainable, because guess what? That's not a skill set I work on every day.
Yeah.
But Kotlin is something I work on pretty much every day, right? Like,
Yeah.
so I can identify things, and because those are all written in Kotlin, I still get the same click-throughs. I still get the same dependencies and imports and all that kind of stuff. So I can really do and take advantage of a lot of powerful tooling around it.
That's awesome. And so just to, because we did talk about it a little bit, there was an earlier question around going from like Groovy Gradle to the Kotlin Gradle DSL. So how the migration, so how would you, being that many apps out there today have existing tech debt, a lot of these tips are great for new app, like they're building a new app and stuff like that. How would you go about, getting to separating out your ProGuard files, and that way your build is a much more future forward, modularized and stuff like that. Addressing the existing tech debt.
So what's kind of nice is you can take it in stages. So you can take your Groovy and you can do a conversion to Kotlin, which is the first step, right? And then starting to split each piece out. Now we can build into a build SRC, and now we can start splitting our dependencies. Or maybe now we can, and then that has its own like build Gradle thing to it. You don't have to move. And I highly suggest you don't move just from like one directly to the end game, because we all know how that works in your code. It won't work. So baby steps. And that's actually what I'm trying to highlight. I've actually been updating kind of an EXO player example project, like video player type project, to actually show you step by step how that all works. And I'm even going to include some extra things that you maybe don't know how to do, or some things I want to update on the Docker like docs. If you aren't familiar with Docker, Docker is basically Java docs for Kotlin, and it has interaction directly with Java docs if you want to use that same nomenclature and everything else like that. But it has 4 different build types, and one of those is HTML, which then you can build into your continuous integration process to build, on an internal page so everyone can see what the methods are and kind of core constructs. And this talks about that growth and that maturity too, right? So if we're talking about making your code accessible, think about it not just in terms of Android teams, right? If you're going to build like a backend service that you're going to be using, say, something that's using just an API. So we'll say like some JSON thing, right? So you have a few options there, right? You have Kotlin Moshi or the like Ktor with the Kotlin serializer, and whatever you need to do in terms of that backend kind of send and forget or handle return values, and you can build that as a KMP project, but now other services on your backend can use that to structure, because a lot of microservices are also structured around like REST services to communicate with each other. And maybe they service in a GraphQL front end or something else like that, right? I'm a big fan of GraphQL right now, so I'll throw that one through. So you can think about how you're actually building services that can be used for others. And by having this build SRC, by having that all structured, you can have your Kotlin projects intermingled with your Android projects, and you don't have to worry about dependencies. And you can have auto-generated documentation so that other teams immediately know how to use the libraries or components you've built. It sounds quite idyllic, but it's actually quite practical and not as difficult as you might think. If I could put it together in a couple of weeks, and show you. And it shouldn't be that bad, right?
Yeah. It sounds relatively easy. And, back to the whole theme of today's show about future proofing. I mean, right there, you're not only making it easier for the rest of your team to help build on the app, you're making it easier for yourself, because you alluded to this earlier. Like, this is not necessarily something that you work on every day, but when you need to come back to edit it or fix it, like, where am I? Where was I? What was I? Because as developers, we all have that code that, what headspace was I in when I wrote this? Like, because I've looked at code that I wrote 3 months ago, and I'm like, who wrote this code? This is not my code, kind of thing. And so that's where doing this kind of thing helps to future-proof your app and really make it easily scalable for you and your team.
Yeah, and scalable services too. And more than anything, as everything has been moving to mobile first, and we've heard that a lot, especially over the last 3 years. And we look at the deployment of Android and other things. How do you actually enable your company to be mobile first? Part of that is through inclusion and creating inclusion as part of your code and part of your thought process. And, we talk about diversity and inclusion. Code inclusion is definitely another topic specifically to bring in. And how do you open up those mindsets? It's by exposing yourself and your tooling past your walled garden. There's what was the theme from The Secret Garden? The fact that it was a secret kind of ruined it in some ways, right? Like, there's so many things to think about that at the end of the day, you're not paid to be an Android developer. You are paid to be a solution engineer. And I'm certainly not ever going to be close to being the best Android engineer. I don't plan on it, but I hope that I can solve the problems I'm being paid to do.
Definitely. You're one of the best that I know, and I'm fortunate enough to have known you for many years. So you're definitely the top in my book.
Oh,
on that one.
please. I have so many other people that I grovel at the feet at.
Awesome. So we do have another question here, and those of you who are asking questions, continue to ask questions. These are great. We do have one here from username Gubar. What do you see as some practical use cases for integrating KMP into existing apps? So I guess this kind of goes back to what I alluded to earlier with the tech debt or whatever. A lot of these folks that are watching us, they aren't necessarily building new apps. How do I use these new features that we're talking about here today in our existing apps and upgrade them to be future proof?
So, one of the wonderful things about being in the tech space is that code rarely lasts longer than 18 to 24 months. And really, it's looking at opportunities that you have where they're going to be doing API changes, right? And you're like going, oh my gosh, the way that this works is so, statically integrated everywhere in my application. Why don't I just start with something on API? Because, and I bring this up because API is something that everybody has to touch, right? So it could be something that you share, especially if API is updating. This is one of those things that you can share with like an iOS team, right?
And the
Or
web team and
oh yeah, everybody, right? So that's one thing, right? So there's potential extra value there. But even thinking about it from yourself, being able to actually containerize and start thinking about how do I separate things out and real separation of concerns, not just like, okay, I have my view model here, I have my activity here, I have my custom view here, all that kind of stuff, right? We think about those architecture views in terms of very relatively low level, like the class level, right? Start thinking about how do I take that kind of idea and apply it to a higher level thing. So I would, unless there's like some impetus, always try to work these things into your process stream. That's the thing that I've found that works the most, is not to say, hey, we need to do this to address tech debt, but to say, hey, we have to do this. We might as well, also move our processes and bring this tech debt. It might have a slight scope creep, but if we plan for it effectively, if we kind of make these things, this will make our code more maintainable. And one thing to say is like, hey, if we do this as a KMP thing, this might become even just a framework that other people can use to understand if they want to build their own. It doesn't have to be, never force it on anyone. Bring in people early if you are thinking these processes through, just to see if anybody else really needs it. You might find that some security team also needs to be able to use this API to maybe run some sort of automated testing on their APIs or other security things. So they might also need a piece of client code that you're writing. They just don't have the ability to write it. So I guess there are a number of practical use cases and reasons to kind of frame your thinking in terms of how you're actually putting your code together.
Yeah, and back to an example we gave earlier, wherein I brought up Cloud Run. I mean, so this way you're able to write your own backend process as a Kotlin developer, and that's where KMP comes in, to help you out here. But yeah, thank you. There's a lot of other great examples that Stacy just gave on the use cases for bringing in KMP. Are there any industries that you can think of that you've seen KMP more used so far? Like what industries are really adopting it?
So a lot of these are kind of SaaS companies that are using it to generate multiple products. And they've had to finagle with a lot of things in the past, or even have multiple teams with a lot of context switching. So when you're thinking about being able to do multiple generations of clients with maybe just slight tweaking per platform, if any, that has a lot of value. And when we think about especially larger companies, there's a lot of those applications, right? Where there are multiple clients for one specific thing. Do you think that let's throw this out there. Do you think Microsoft is rewriting its login client for every single application that uses it? Do you think they're probably using, some sort of core? Do you think that's true of pretty much everyone, right? Like we're thinking about Twitter login, Facebook login. They're not going to be rewriting every single core of that application for every single platform, are they? So maybe even think about that in your own world and your own applications. I can't say that they are necessarily using KMP by any means, but I do know of a number of companies that are using it to actually bring out multiple distributables because and have been for a while. And then some other companies, large ones that have been working with some well-known contracting firms to actually build out KMP style infrastructure. So, I'm not going to name drop as much here because I don't have any kind of authorization and I don't want to throw friends under the bus.
Yeah, we don't want to throw anybody under the bus. We also don't want you to get in any trouble or anything. But we do have one more question here. We are running a little bit over. Hopefully that's fine with your calendar. So this Omer, I believe. Sorry. Should we use Kotlin DSL, Kotlin Gradle DSL, or is there any drawback using WRT Groovy?
So yeah, mainly the drawbacks that you're actually going to be facing at the moment are going to be in your ability to really split out code, really bring in separation of concerns, and your compile times. I will tell you that in a project I was recently a part of, not a small, build, but had multiple components. Even before we were splitting it out into modules, just going from a Groovy Gradle to a Kotlin Gradle, we instantly went from approximately 2 minutes to about 40 seconds.
Oh, wow.
Yeah.
That's huge.
I can't say that that's going to be what everyone experiences. And that was just a direct translation. We weren't even tying into some of the other things. That was just doing the build SRC stuff. Not even, it was one step above the Groovy to Kotlin. But just in the basic build SRC, built the same components thing, migration. We saw that level of
awesome
optimization. So part of this is also related to the tooling. They've done a lot of work to optimize Kotlin Gradle DSL, especially in the Gradle tooling. Yay, Gradle folks. Thank you very much. So you can even see that they're kind of pushing towards that, whether or not they have the documentation to align with it. They are building out the tool sets that make that much more compelling.
Awesome. And so there was a lot of optimization. There was a lot of, your build time decreased. So there really wasn't that much of a drawback on moving from Groovy to Kotlin DSL.
There was none.
None, like except for, I guess the only thing that if you're looking at it as like a dev manager or something like that, it was just the develop time was really the only, you had to migrate from one to the other. So hopefully that answers the question on that one. Great question. All great questions all around. I know we are over, but I do know we also slated to talk about Jetpack Compose. So if you want to quickly, how does Jetpack Compose fit into all of this?
So now that you're thinking about really modularity, and that nothing feels sweeter than that little GitHub thing at the bottom that says 100% Kotlin, not 99.9% because you got some Groovy in there. Yeah. You might have some CI framework thing too, so you can't make it all work, but now we can start to think about that same kind of modularity that Jetpack Compose enforces just by its own inherent building. And I think that you see some parallels here in terms of the Kotlin Gradle DSL and Jetpack Compose, where there isn't necessarily a tool to convert because the thought process is slightly different, right? So when we talk about XML layouts versus Jetpack Compose, there is a community tool which kind of just highlights, some things that you should think about. But you really have to think about how you're even structuring things, or you should be thinking about how you want to structure things. And with Jetpack Compose, we have all gotten so used to recycler view hell. Oops, bad word, but it absolutely exists. And kind of third-party libraries around recycler views. I'm a fan of Lisa Ray's Groupie, and I've played around with the Airbnb epoxy. It's Airbnb, right? Epoxy stuff for that. Which does force much better separation of concerns. But if we look at lazy row and lazy column, which are the analogs for recycler views, we really see how that forces that same kind of itemized structure, right? So we're moving into the separate your do not have a pile of code in your adapter. You can't. You have to have the item view, the adapter piece, all this other stuff, right? And we're forcing that kind of behavior. So that's where like the thought process is interesting to me, at least, because I can see that they are inherently informing ideas of architecture and this same style of kind of architectural thought process, at least. Maybe not even, in all the components I've talked about, but doing that in terms of our UI. Now we've got view models in our code, so we're really structured more towards the MVI or MVVM style of building. And, live data is dead, long live live data. So now we have flows, right? So shared flow and state flow and just regular Kotlin flows in that place, right? So, and those force the same kind of thing. So we're really seeing that all of these things are actually all together. And it's maybe this might be the last thing that gets touched on, because I know they're doing a lot of work. They just rebuilt a lot of ththings in fragments and the nav controllers up, at least according to tweets by Ian Lake. So when we really want to have these kind of ideas, and when we structure our build architecture to inform our app architecture, to inform our data architecture, which then aligns with our UI architecture in Jetpack Compose. All of these things are dependent. And we might be moving a little bit from front to back, but really, this stuff I've kind of been bringing up, it's not something you're going to find in a lot of videos, but
Right.
it's something that a lot of the big names have been doing for years. Maybe not necessarily with Kotlin Gradle DSL, but all of the architectural constructs behind that, and just how that actually enables those thought constructs to be more organized.
Definitely. And that's why I wanted to make sure we did touch on this, just because of how important it is to like the updates and the announcements that have been happening, this spring. And, you have obviously a lot of experience with this. And so thank you so much for sharing your knowledge in this space. I do want to be mindful of time here, and because I know you have other meetings to get to. This is the middle of your day, so thank you so much for joining us, Stacy. This has been an amazing, enlightening. I know I've learned a lot about how all of this comes together in modern Android and Kotlin architecture, building an app, how to make things future-proof, how to make things, more optimized, and not run into those build time errors that all of us see. There's a lot of amazing stuff happening in the chat, so please go back and scroll through the chat. There's a lot. You have a lot of fans in the chat here, so I know I'm one of them. So thank you so much for joining us, Stacy.
Thank you so much, Kyle. I love talking about this stuff, obviously.
obviously. And so for everybody who joined us today, thank you so much. Stay tuned for our future episodes. You can register to be first to know about them on goo.gle/between the brackets. That way, you can see more about our past speakers and who we have upcoming. And we're very excited for the rest of the episodes that we have planned for this year. And again, thank you so much, Stacy. I believe that is your Twitter handle that everybody can find right here.
And never be afraid to ask me questions. My DMs are open. Don't be weird or creepy. That's how you get blocked. But
Yeah.
I'm always available and love helping people. You would not believe how many impromptu calls I get on to help people with all kinds of problems or even thought processes. So please do reach out if you have questions.
Definitely. And thank you for being available to do those questions. So if we didn't get to your question today, or you're watching this later and you do have a question for Stacy about any of the topics covered today, please reach out. You can also reach out to us if you have a particular topic that you're interested in seeing on Between the Brackets. We'd love to hear what you out there are interested in hearing, so that way we could bring in other great speakers like Stacy. And so Stacy, you are also part of our community programs as well. So GDG, the Google Developer Groups, Women Tech Makers. Any parting words on any of that?
Just that we still have a couple of amazing IWD events that are coming up. And more than anything, this Saturday, I'm going to throw a quick promo out for my Flutteristas out there. If you aren't familiar with them, this Saturday is the Flutteristas conference. It is up and open registration and open to everyone. So please get on, and high availability. So if you've been interested in Flutter, which, me personally, like, I might get paid to do Android development, but hey, you gotta know everything. You gotta know a little bit of everything, right? Like, and maybe it's a solution that works better for you. So I think it's just really important that you keep your ear to the ground. And one of the best things you can do is especially support the Flutteristas, a women's Flutter group, and just some of the amazing content and brilliant women that are going to be speaking on all things Flutter.
Yes, and I know we like to throw around acronyms on the show and stuff like that. So IWD is International Women's Day, and so if you look up some of our Google Developer Groups and our Women Tech Makers, they are still hosting International Women's Day events, as Stacy was mentioning. So please look those up and join as well. They're great events. You hear about a lot of amazing stuff happening.
Thank you very much, Kyle.
Thank you.
I've had a great time.
It was great having you, and hopefully we can have you back again soon.
Awesome.
Awesome. Thanks.